This is Newton's first law of motion. This is a free body diagram of all the forces that were acting on the domino in the Rube Goldberg machine. You had the force of the push, which is calculated to be 20 newtons. You had the force of friction, pushing back on it from the wooden table. You had the force of gravity, or mass times gravity. Then you have the normal force that was pushing straight back up on it from the table. Now the question is, was this traveling at a constant velocity, or was it accelerating? In order to find this, we got to decide, is the force of the push 20 newtons equal to the push of the force of friction? Well, one easy way to find this out is to use the equation force of friction equals mu times F of n. And if that equals force of the push, then that means it was traveling at a constant velocity. If it does not equal that, that means it is accelerating. Okay, so you have the force of the push, which was 20 newtons. You have the force of the mass times gravity, which was 0.177561. The normal force was the same as the force of the mass times gravity, since it's the same exact force that's being pushed back up. Then you have mu, which is 0.25 for plastic on wood. Okay, so when you come over here and you start doing all your calculations, you get 0.25 times 0.177561, and that totals out to be 0.044 friction that was acting on the domino when it was being pushed, which means that they do not equal each other, which means that it was not traveling at a constant velocity, and it was indeed accelerating, which leads you to the equation force equals mass times acceleration. So you plug in your numbers. You know that it was being pushed at the force of 20 newtons. Its mass was 0.177561 times a. So you divide both sides by the mass, and you get an acceleration of 112.64.